We have in the UK the best supply system in the world. It's a super grid. It is already a smart grid. And I don't know if you can remember when you lost your electricity last at home, but it's a great system. And it's the largest supply engine in the UK. And it's been going for a good 60 years now, since the Electricity Board was formed. Why can't we just simply plug and go? Why can't we just simply connect in? Grid systems are very, very complex. And that is a map to show you the density of the cables. On the right-hand side, you can see 58,000 kilometres of cables. There's thousands of transformer points, so that would include ground-mounted substations or substations up a pole. If you look on the left-hand side, you can see that there are several different grids. So this is just in this area alone. This is not including National Grid with the big power lines. We have 5 different grid systems, or 4 different grid systems if you like. And all those grid systems are at different voltages. And they're all interconnected. And the top end ones, the bottom 2, the black one and the green one, they are automatic systems. So if one bit switches out, another bit switches in. It's all controlled. It's a fantastic system. There's a problem with all this here. Some of this, it's 40 to 60 years old, and it's going to have to be changed. And it will cost literally billions to renew it and change it. So that's why we're talking about smart meters, smart grids. And unfortunately, it's the customer that wants the product that is going to end up paying for all this to be renewed and changed and upgraded. So that's Electricity North West. They're an excellent company. They're very, very open. What I would say to anybody that rings me up and says, Geoff, I want to do a project, or I want to do a 1 megawatt project, half a megawatt project, I want to put 11 kilowatt turbine up, or I want to do a PV project on several buildings. There's 3 things you must consider right at the beginning. If you've not got a grid connection at the right cost for your project, you haven't got a project. Because there's no point in spending thousands of pounds and after 12 months or 18 months, finding that you can get the planning permission and environmental consents are looking good, but the grid connection costs are going to blow all the project modelling costs out because the grid connection is too expensive. 70% of rural supplies only have single phase. In a lot of these areas, there's no 3-phase. So there is a bit of a restriction on what type of size of project you can do in a particular area. Electricity North West are a little bit more proactive than some other DNOs, distribution network owners, in that they will consider up to 50 kilowatts now, a single phase connection onto the system in a rural area. But it is subject to a network study, and it is subject to certain conditions, so it's not automatic. So any project needs to have a view of what the connection costs are going to be from the DNO. This is a photograph very near where I live. I live in a place called Rivington, so it's 1 mile from my house, and this is a hill farmer who's got a bit of a caravan park. And he got a grid connection for nothing, because his 11 kilowatt turbine, under MCS rules, could go ahead and proceed, and he could connect to his supply. It's a 3-phase supply. You see the 3 red lines. With that, you could connect 3-phase generator to that up to just over 11 kilowatts. So MCS, they can go ahead and do it. You don't have to ask the DNO for permission. So if you're going to ask me the question about single phase, the level of project, the size of project that you can produce, 3.8 kilowatts on single phase. So under that, or just up to 4 kilowatts, you can go ahead and install your project. One project, you can go ahead and do it, and you don't have to ask for permission from the DNO. Anything bigger than that, you have to go to the DNO, submit your request, and ask for permission to connect. If you're going around looking at particular supplies, or you're a planner and you're out in a field, and someone's giving you an application for 50 or 100 kilowatts, and there's only this type of supply system, there's no 3-phase connection there. You will not be able to connect to this particular line over 50 kilowatts. So there's very limited connectivity on this. One of the things that every project must have, it's essential, is that you engage a competent and approved installer who understands a lot of these issues and on your behalf can approach planning, or they can approach the particular DNO for a connection agreement. Bigger projects require a connection agreement. There's three things that you can ask the DNO for. Budgetary quote, initial view, will not cost you anything. It's free. It'll give you a budgetary view of the likely connection for your project, providing you submit the right information to them. Feasibility study, not really for small projects. Bigger projects, they're likely to charge you for that. Could be anything from £3,000 up to £10,000, depending on how big your project is. So if it was a wind farm of 10 megawatts, they'd be probably charging you about £10,000 to do a feasibility study. Or you can ask for firm costs. You don't pay for a firm quotation and costs. That is free. But what you need to appreciate, to get your firm costs, you have to put a firm design in. So you need a very approved consultant or designer or installer to do that on your behalf. And the DNO is responsible under Ofgem rules for, they do not work the system. They are responsible for giving you the least cost option of connection. They have to do that under the Ofgem rules. Why is it so complicated? It is very, very complicated. The reason why it is so complicated is the grid systems were never designed to have renewable generation. What renewable generation does, connected into grid systems, it makes them unstable. It pushes the voltage up. So in rural areas, it's a bit more of a problem. The DNO has to look at connecting a generator. He has to look at what other generation is already in the area, the increasing generation, and you have to maintain the voltage 24/7. So they have to ensure quality of supply to every customer and that the voltage does not go out of the permitted limits. If it does, you end up with customers having damaged electronics, not very happy customers. So typical costs of what you could be paying for your grid connection. The bigger your project, the more expensive it is. Case studies, right. These are projects that I've supported and helped. This one in Chorley, quite a big wind farm. You can see the grid connection cost is £235,000 there. And that's because he needs his own substation to connect these wind turbines. We saved him about £50,000 to £60,000 by coming up with some alternatives. When you go into bigger projects, there are options that you can look at. The grid connection doesn't have to be just done by the DNO, by Electricity North West. It can be done by an approved contractor. The approved contractor will do the work at a rate that's a lot less than the distribution network owner will do it. So we saved him about £50,000 or £60,000 with that one. Big problem with this project, be aware of this. If you're a planner, ask these questions. Sometimes to connect up a renewable energy project is not easy. You have to go over third-party land. This is a classic example. 1 kilometre had to go over a third-party land, and a neighbouring farmer who initially agreed, but then he sold the land to a future venture capitalist in London, and he wanted £1 million to pass his land. And I think they agreed eventually £500,000. This project's probably going to return about £15 to £20 million with the ROCs or the feed-in tariff. So it gives you some idea. It's £1 million a megawatt to put up, roughly. This is the turbine that's near me. Grid connection was 0. So, very happy farmer here. It was about £65,000 to put up. And the return on the FIT and the offsetting his energy that he needs from the grid, he's making around about £8,000 to £12,000 a year. So it pays for itself in about 5 to 7 years, depending on how the wind blows. And then he's got 13 years, probably at £130,000 less his tax. So he's a very happy farmer. He's thinking of putting another one up. There are other things that have to be considered for projects. The main one are legal agreements and cable consents on third-party land. So if you're looking at projects, you might be wanting to say, how are you going to get your cable to the connection point? How does your neighbour feel about it? If he's opposing the wind turbine, he's opposing the project, he's not likely to agree to a consent. And sometimes to go around the public highway to get a connection can be quite a distance. The final one, this is another project. We just obtained a budgetary quotation for this proposed project. Planning and environmental issues are progressing. It's looking very positive. It's a community project. It's been calculated that probably if we could extract so much water, we could have a 50 kilowatt turbine. So that will be, it will be three-phase. Broad Rain, I think it is, Killington. And it's not too far from the grid connection, which is a good thing. It's about 200 metres away. Okay, that's the access going down to the weir, and that is the area supplying transformer. It's supplying about 5 or 6 houses. And what is required, you see the overhead lines, we will have to connect to these overhead lines. And here is a plan. So that shows you where the weir is, where B is. A new overhead pole transformer would have to go up there, and a new high voltage cable laid down to A, which is the existing overhead line. The estimated indicative costs for that from Electricity North West are about £55,000 to £65,000. The first question that I get from the community project is, why can't we connect to the existing cables? Why can't we just connect to the cables that are feeding the house? Because if that was possible, the connection cost would be about £2,500. And the reason why they can't connect it, the generation is too big, and it will increase the voltage and affect the voltage so much that it will damage the equipment in the houses. And then you've got customers who are not very happy complaining to the network owner. So the reason why we've got these high costs is because these are very large projects, large generation, large amounts of power, and they need to be connected into the system at the right place. So there's a lot of things have to be considered with projects right at the beginning. Essentially, just as someone has got to consider planning, they've got to consider what the grid connection costs are going to be. Because if you've not got a grid connection cost at the right price, if you're in a rural area, it can undermine your investment modelling and your feed-in tariff return.